Okay, so hi guys. In the last video, we learned what the power rule was, which essentially stated if you had a times x to the power of n, the differentiated function, which we learned was dy over dx in terms of notation, could be seen as n times a to the power times x to the power of n minus 1. Now, let's learn about a new rule known as the chain rule. And this is very helpful when evaluating very complicated lists of things. So let's say we had the function 3 times x squared plus 4 to the power of 8. Well, differentiating it would be very much a pain because it would force, well, at first glance, by power rule standards, we'd have to open this whole thing up and then evaluate each term separately. But there's a way of simplifying that with the chain rule. So essentially, the way we would do that is we would divide it into parts. So we could say that this middle part, this part which is x squared plus 4 in the brackets, is known as u. And we can write this again as 3u to the power of 8. Now, what we can do is differentiate what we have here with 3u to the power of 8 in terms of u. So do we do d over du. So, or dy over du, whatever, because it depends. So we could do d over du, which is the differential way of writing it, is equal to, and then we use power rule. So 8 times 3 is 24, and then we bring the power down. It's 24u to the power of 7. Now we're not done yet with this. What we then need to do is differentiate what we have in the function. So x squared plus 4, how would we differentiate that? X squared plus 4. Well, the way we differentiate it is bring this down and then decrease the power, so 2x. And then the constant, we remember, does not have anything, so it's just 2x. So the way we do this now is we would write this as 24u to the power of 7 times 2x. You multiply it by the differentiated function, which gives you 48x times u to the power of 7, because you can just multiply it by 24. Now, we're not done. We can't just leave it in terms of u, right? We have to substitute the u back in, which would give us 48x times x squared plus 4, and then to the power of 7. So that's our differentiated function. And by using chain rule, we could easily simplify this. Let's do a couple more examples. All right, let's look at this one. So immediately, we should first identify our u. In this case, u is this middle term, so we can write this as 7 over 2u to the power of 4. Typically, I'd pick a u that's in the brackets, because then it's very easy to substitute right back in. Now we use the power rule to simplify this. So bring the 4 down, that's 7 over 2 times 4, which is just 14. So we have 14u, and then the power is decreased by 1, so 14u cubed. But we don't stop there, we also have to differentiate this function. So 3x squared plus 4x plus 3. We can use the same rules with the power rule, so that would become 3 times 2, which is just 6x, and then the squared becomes 1, because 2 minus 1 is just 1. Plus, and then it becomes 4, because using the power rule, this can be simplified to 4. And then, of course, the constant doesn't have anything. So it's just 6x plus 4. So now, we would multiply that by the 14u cubed. So that becomes 14u cubed times 6x plus 4. And make sure you multiply everything by that. So that would become 64, no, not 64, sorry. You have to do 14 times 6, which is 84. 84 xu cubed plus, and then 14 times 4, which is just 56. 56u cubed. And now, what we can do is substitute the value of u in. So that becomes 84x times, and then u is 3x squared plus 4x plus 3 to the power of 3, plus 56. Then we substitute that again, 3x squared plus 4x plus 3 to the power of 3. And a very easy way of simplifying this would then be to factorize it, which would become 84x plus 56 times 3x squared plus 4x plus 3 cubed. And that's the final answer. So you'd write it as f the derivative of f of x is equal to 84x plus 56 times 3x squared plus 4x plus 3 cubed. Alright guys, so to conclude the video, I've made a little 5-step checklist when looking at really like big binomial looking things, and that you have to differentiate. So typically you'll be getting things that look like binomials when you have to use chain rule, because they typically relate to a huge bracket or binomial being raised to a high power. So to simplify, you'd use chain rule. So first step is to identify the u value, typically held in the bracket. The second step is the use of the power rule to differentiate with respect to u, because you would have replaced that value that you identify as the u value with u, and then use the power rule to differentiate it with respect to u. Step 3 is to, I didn't mention differentiate the value held by u. So the value you replaced with u, you have to differentiate that on its own as well. Then step 4, multiply the two derivatives. By the two derivatives, so derivative is basically the differentiated equation. So if you have 2x squared, 2x would be the differentiated equation. So you would multiply the power rule differential, which would say, for example, if you had 48u cubed and u was equal to 2x, then this would be what I was referring to in step 2. But in step 3, I'd be referring to this differentiated part. So you multiply the two together, and then after that, you substitute the value of u back in. So you'd substitute 2x back in there. You wouldn't just leave it in terms of u and x. You only can have one variable left. So those are the 5 steps, and those should help you solve any chain rule problem. So thanks for watching.